given a problem, y equals minus x plus 3 and y equals x minus 2. So in simultaneous equations, there are two ways to solve this problem. We can either use the graphical method or we can use the algebraic method. Now, one thing we must recognize is from these two equations is that they are both linear equations, and they are in the form of y equals mx plus c. So to solve the problem, we need to plot the lines of both equations on the same graph, and where the two lines cross, this will give us the solution to the problem in the form of the two x and y coordinates where the intersection occurs. Now we're ready to consider choosing our range of values of x, but we need to consider these values carefully so that the two lines intersect at a suitable point on the graph. And to help us visualize these range of values, if we now draw an x and a y axes, we can actually divide this graph up into 4 areas, and we'll call the areas, we'll number the areas 1, 2, 3 and 4. So if we look in sector 1, we can see that to draw a graph in this particular section, we must have both our x and y values as positive. In sector 2, the x is still positive, but this time the y value is negative. Sector 3, we can see that both the x and the y values in this sector are both negative. And finally, in sector 4, the x is negative and the y value is positive. Let's look at the two equations that we've got and see where the lines of these equations form in terms of the sectors that we just looked at on the graphs. And let's name the two equations. We'll name the top one equation 1 and the second equation 2. Okay, so taking equation 1, y equals minus x plus 3, we can see that because y is positive and x is negative, we can see that if we were to draw this line, the line would fall into sector 4. And similarly, if we took the second equation, y equals x minus 2, because both x and y are now both positive, that this graph, or the line of this graph, will form in sector 1. We must also further consider the fact that we've got the offsets values of c in both equations. We have the plus 3 and we have the minus 2 in the second equation, and this will determine at what point the line starts where the line cuts the y-axis. So in equation 1, we're going to see a line going off to the left hand side, okay, but it will be offset by a value of 3 on the y-axis. So the 3 would be there. But on the equation 2, yeah, the line would be offset by a value of minus 2. So we know therefore the equation for line 2 is going to go off in this direction, and that will be minus 2, and 0 will be somewhere around about there. So we can complete the visualization now, and we can see that the intersection point is going to be somewhere between either sector 1 or sector 2. For our values of x, they only really need to be in the positive direction. So really, we just need to generate a range of values from x equals 0 up to a suitable value, and we can effectively chin off this side of the graph altogether. So that way then we can use this area of the graph for maximizing our working area and therefore increase our accuracy. In this example, we can gauge that the intersection point will result in small values in terms of the x and y coordinates, so we can choose a relatively small range of values for x, and let's say between 0 and 4 with a midpoint of 2. So let's start with equation 1. Let's make a table. So just put this up at 1, x and y, and then we'll put in our values of x, 0, 2 and 4. Often 3 values will do. And now all we need to do is to calculate the values of y. So when x is 0, y is 3. When x is 2, y will be 1. And when x is 4, y will be minus 1. And we'll do the same for equation 2. X in the same range, 0, 2 and 4, and our y values. And if we now substitute each value of x into our equation number 2, we'll get when x is 0, y will equal minus 2. When x is 2, y will equal 0. And finally, when x is 4, y will equal 2. And so what we'll do now for equation 1, we can plot our points on the graph. So we'll plot the 3 points that we've got. So when x is 0, we'll plot 3 for y. X is 2, y is 1, and x is 4, y is minus 1. And then we'll do the same for equation 2. This time x is equal to 0, y is minus 2, x is 2, y is 0, and x is 4, y is 2. And now, just using a ruler, we will complete the 2 lines using the best fit technique. And there's the line for equation 1. And there's the line for equation 2. And finally, all we need to do now is to draw a line vertical and horizontal to read off the 2 coordinates where the intersection point occurs, and that will give us our values for x and y, which, as we can see, is a value of 2.5 for x and 0.5 for y.